Good morning, ladies and gentlemen. I'm going to go through a couple problems of balancing chemical equations, hopefully to clear up the air a little bit. I know some people were struggling with these, and it can be kind of a hard thing to wrap your head around when you first start doing them, but once you really get into the feel for how to do these, they get a lot easier. So let's just kind of break down one of these chemical equations first. I'm going to look at number 4 here for starters. And with number 4, whenever you look at one of these problems, you're always going to have one of these arrows. We call that a yield sign in chemistry, and everything to the left of the yield sign are your products, as we've learned, and then everything before is the reactants, and everything after is the products. So we have Fe, which is iron, and then we have O2, which is oxygen, and then it yields iron oxide, Fe2O3. Right. Well, what we have to do is we have to go through and we have to balance this equation. So all of these little numbers that are already in the equation, like this 2, and this 3, those are the number of atoms within that particular molecule. Okay. We can't change those. Okay. But what we can do is we can change the number of molecules. So we can't change those little tiny numbers that are already in there, but we can go through and we can add in numbers or coefficients in front of every single one of these. So what we can go through is we can go through and I could put a 4 in front of this, or I could put a 2 in front of this, right? Those kind of things I can go through and do. So my whole goal is to get the whole equation balanced. And in this particular equation, I have Fe and I have oxygen. Okay. So I want to get my irons on the left and right of the yield sign to be the same, and my oxygens on the left and right of the yield sign to be the same as well. Okay, so what I like to do is I like to go and start off by just saying, okay, Fe, I have 1 over here, and I have 2 over here. Well, how can I balance those? Okay, well, I could go ahead and create 2 then. Okay, so I could have 2 over here. Okay, now, if I go ahead and look at this, now it would show that I have 2 irons on each side. Okay, so my irons are good. But now I look at my oxygens. Okay, I have 2 oxygens over here, and I have 3 oxygens over here. Okay, now you can't put like 1.5. Like I couldn't go through and I couldn't put 1.5 here because you can't have 1.5 molecules. All right, so that doesn't work. But what I can do is I can find, if you guys remember from math class, a least common multiple of these two. All right, and that would be 6. All right, a least common multiple of 2 and 3 would be 6. So um, if I can get both of those oxygens to add up to 6, so in order to do that, I would have to put a 3 out front here, and I would have to put a 2 out front here. Now I have a grand total of 6 oxygens. Okay, but now we ran into one more issue. Okay, if you noticed, as soon as I put that 2 in front of the Fe2O3, well, now what I've done on this side is because I have 2 right here on the Fe, and I also have a 2 out front, what we essentially end up doing is multiplying those two. So I really have 4 irons right there. So because I have 4 irons on the product side, now I have to go back and I just have to change this to be a 4. So now my grand total for number of irons is 4 irons, and I have 6 oxygens. Okay? So that is a balanced equation right there. That's one of the smaller ones. I can go through one of these longer ones as well. Let's go ahead and Let's go through number 5 here. I think that's probably a good one to go through. Okay. All right, so looking at number 5. Okay, if it ever helped you to just kind of make yourself um, a line down the middle or something, just to kind of show you, okay, here's where my products are, here's where my reactants are, that sort of thing. When you get to some of these longer equations, one thing, oh, sorry about that. Sorry about that. I was going to go shut that beeping noise off, and then all of a sudden it stopped. So one thing that with these longer equations is you're going to notice that sometimes there's clumped together common elements that are clumped together. So for instance, we have this NO3 here. So we have NO3, and then on this side we also have NO3. We also have CrO4, and on this side we have CrO4. All right, those are called polyatomic ions. All right, and we didn't do too much with them this year, just due to distance learning, and they're a little bit. You'll learn more about those when you get into chemistry as a junior. But we basically can treat those polyatomic ions kind of as one clump, all right? And that'll really kind of help as we go through this, just to kind of balance these equations out. Okay, so I'm going to treat it like this. I'm going to say I'm looking to balance my number of PB, which I'm sorry is not peanut butter, that is lead. My number of NO3s, and then I'm looking to balance my number of Ks, or potassiums, and then finally I'm looking to balance my number of CrO4s. Okay, so there's 4 things there that I'm trying to balance out, and I want to get to be the same on each side. So let's just start with PB. So let's start with lead. I have 1 lead over here and 1 lead over here. Okay, so far so good. All right, now let's go to NO3. All right, my next one, NO3. When you have this parentheses here, this is showing you that this NO3, that little 2 on the outside of the parentheses, it's multiplying that entire NO3 by 2. So there are 2 NO3s on this side. Okay, well, over on this side, I only have 1 NO3. So what I need to do in order to fix that is I need to put a coefficient out front. So I'm going to put a coefficient of 2 out front. And now I have 2 NO3s on each side. Okay, now I'm going to go look at my next one. How many potassiums do I have, or Ks? Okay, so I have 2 potassiums over here. And look at that. That one right there just fixed itself. I have 2 potassiums over here. Okay, and then finally we have to go through and say CrO4s. I have 1 over here, and I have 1 over here. Okay, that one actually ended up being pretty easy because there wasn't a whole lot of changing numbers. All right, but what will happen is as you go through this, sorry, and I guess I can kind of put these in here. So we ended up with 1 lead, 2 NO3s, 2 potassiums, and 1 CrO4. What will end up happening is sometimes you'll end up going through and you'll end up going back and kind of changing things because one number that you added in might affect something else. Kind of like number 4 that we did before. We went back and we had to change the number of irons due to the fact that when we changed something else, it just kind of affected it. So there's kind of this process of what I would suggest to you is just start off with your first element and just kind of go down the line. Okay, here's my lead. How many leads do I have? And how many leads do I need on the other side? Right? And just kind of go through that for each element. Right? Or in the case of like a polyatomic like CrO4, you could do that as well. So if you guys have any other questions regarding this, please make sure you let me know. I really hope this video helps. But if you still need a little bit of extra help, please let me know. Have a good day.